All right, good morning, everyone. Welcome back to another installment of AI BDS 1. Last week you had like a holiday from me, so I wasn't there. Um, but today we're going to continue. And so, first, what I want to do is I want to summarize a little bit what we did so far, and then we're going to go right over the next important process step, which is data preparation. This is a little bit more hands-on because we are addressing some really important issues that arise in predictive modeling, and I will show you how they affect also the model. So this is one of the main goals for us, is not just to show you, okay, what is a mean, what do we do with the median, but also why is it important for us to sometimes, not always, to look at these statistics, to look at these numbers. And today we're going to focus on data preparation. So what kind of data problems are there? How can we detect them? How can we diagnose them with the tools that we already know, that we already learned in data understanding? And then how could we, most importantly, how could we fix them, or can we even fix them? So it's not always uh, easy just saying, okay, we can fix it or not. Sometimes it doesn't work, or sometimes it isn't. It is just fixable to a certain amount, and we have to discuss it. There will be a lot of discussion for some problems if we can actually fix it, if it is worth it fixing it, right? Or just sometimes we delete a portion of the data and so on. But what I want to do first is that this is basically the last. So what you see here, this is slides. This is the last section that we already spoke about of the data understanding. And as you see, the slides are not over. So I want that this is the end of the actual theoretical part. But as you know, we strive to give you some practical insights to let you practice what we have learned. So on the one hand side, you have the data camp for that. So there are data camp courses. On the other side, I wanted to give you an additional purely optional. So this is purely optional. Uh, an example that really shows and comments the procedure of data understanding based on a very, yeah, it's kind of famous human resource data set. So I'm not going to go through all of this. So you can, it's designed that you can look at it, that you can try to figure it out yourself. So it's more like a self-learning thing. But I want to give you like some pointers, some notes, and want to show you what's in it to maybe motivate you to actually do it when you have some time. As I said, it's optional. There will be no questions about the specific data set or specific procedures or Python packages in the exam, right? So don't worry about it. However, this is uh, this is it when I talk about going the extra mile, because you maybe if you want to have a career in that, or you're prone to data analytics, you really like it. A lot of you are OBA students, so I expect you to like know these things, and you can put this pretty much to work in every context. Even if you're like a marketing analyst, even if you're like studying everything else, anything else, this will be really important to you to visualize data, get an insight. You basically have to do this in every kind of job you're in. So nowadays, where we have data-driven organizations. So I encourage you to do this. So we have this data set, approximately 1500, 1500 rows. And so what we have is we have some variables that you can see here, and it's about employee retention. So how can we keep the good employees in our company? So this is the question. This is the goal. This is our business understanding. This is our data mining goals. If you need more business understanding, you can have more information if you search for it on Kaggle. But obviously, this is like this is like the data set. So you can see we have variables for each employee that indicate on that have some indications that are some properties of this employee, like you have average monthly hours, time spent in company, work accident left, if the employee left the workplace or not. So this is data of past employees, right? Or employees that are still there if they have not left. So this could be a target variable and so on. But here it's about data understanding, right? So it goes from, okay, we're gonna do every step here. So, but here it's about data understanding, right? So how do we load the libraries? What kind of libraries do we need? How can we like visualize the data? And you see we have a lot of code, like the code is commented here, right? So the code is commented, you understand this. These are helper functions. What do they do? What are the specific ideas of the helper function? This is very important. So this is just like configuring it. And then we always have these things where we say, okay, what's up? And then we explain the output. This is very important. We show you what the output actually is. What does this mean? How can you get this? So for example, how do I look at the data set? How do I simply look at the data set? How do I get this information? Like how many columns do I have? How many rows have are there any like missing values and so on. So we can do this, like we have features, minimum period of observation, time spent in company, and so on. So we have a lot of information, and it goes on, and we go from easy things like histograms that you already learned, right? So these are the things that you already learned. But also other cool things, like from the Seaborn package, which is a real powerful package. Also looks a little bit nicer than that. It's just your standard like blue histogram. But we have a lot of things that we can look at. So compare groups in our company with small helper function. We can see, we can just look at the persons like who left, who did not leave, and so on. So left, these are the people who left. These are the people who did not left, and so on. So we can do it. We can show it for the different departments, for example. So we can see, okay, what's the distribution here? Then we can look at dependencies, like this is bivariate analysis now, and to show you how we can configure also the plots. This is very important because you want to produce plots for papers, for your masterpieces, for whatever you like, for the management later, how we can configure these plots, and you get an insight into how you can prepare these plots to look the way you like them. Yeah, and then like bimodal shape plots. These are very advanced plots. However, it's explained what they actually do. So it says what it does with regard to the problem. So with a bimodal shape, one peak for the better employees at the lower end satisfaction, another one well spread from medium to high satisfaction. So we can see here how they spread, how the satisfaction level spreads, and then we have left and state. So we have the left people and the state people, so we can see the variable influence, right? So this is pretty cool. Yeah, and so on and so on. So I won't go into detail, but as you see, like at least reading this once and trying to reproduce it once will help you gain an immense understanding of what kind of plots you can use, or even have a look at it and say, okay, this might be a good idea. Or here we have multiple box plots. You already know what the box plot is. Like we have repeated it here for you. And you see like, okay, is there, for example, you also have plots like this where we barely see any difference and so on for the departments and so on. So we have low, medium salary, high salary, and then the count of people, and then there's the salary. We can look at these different, the distribution of the satisfaction level, like what's the distribution with high salary, but we can see that the satisfaction is almost always like the same, the mean, but we can see that the mass in the high salary is more like this, and like with low salary, they are more often dissatisfied, right? So this also shows you the importance of looking at the distribution, right? And we will. I also encourage you to do this later on. To use these plots are universally applicable. You can use them even when you compare different machine learning models. Way later, when we talk about evaluation, and we talk about things like cross-validation, where we apply where we apply multiple models on the same data set, and then we compare them, and we can put a box plot up for this specific model, right? So we have like 10 decision trees, we have 10 neural networks, we have 10 regressions, and we can look how stable they are. Because we could look at just one number, like the mean, we can look at just the mean, but we also need to look at the stability. So if models are down here, then they might not be applicable, because in the business understanding, we defined some conditions for the model to work. And the condition might be that it doesn't go below a certain threshold of accuracy, or whatever measure we have that expresses the success or the prediction quality of a model, right? So these are not just good for looking at the data, so for data understanding, but they are also good, obviously, for evaluation, for the evaluation step. All right. So this I just wanted to show you real quick. So you can click through it. You see, and please look at it. We put some effort into this. So documenting it for you, having a look, and yeah, and writing these slides. So you can, it's purely optional. So you can look at this also. This is very cool. Like these charts are very cool, like excellent plot. So this is a violin plot. This is called a violin plot. It's also very cool. Sometimes used, you might have seen this. So it shows like it's good for comparison. So every plot that is good for comparison with multiple variables is pretty nice. So the standard plots usually don't cover it. Now we are in the, we can see how we divide up the working hours and so on. So I won't go into details. You see, we have quite a lot of these slides, so that don't be like fooled by the number of slides we have. So the theoretical slides are only a portion of that, and the rest is this practical example. So I really like to, oh, I need to correct this. I'm sorry, this is in the way, so I'm trying to fix it. Yeah, so look at this, have a look at this if you want. It's purely optional. And yeah, we can basically have a look at this. But for now, we're going to continue with the data preparation lecture, part of the lecture. Let me just open the slides real quick. Where is it? There we go. Let's go and gonna share it. By the way, while I share it, you might ask yourself what's because I'm frequently switching between factual knowledge on the slides that is not optional. Then I have usually say some general things, almost philosophical things like everything is a process and stuff like this. So, and you kind of maybe get confused because you want a road to the exam. And I understand that. I know that my style can be a little confusing, so it's not just slide, fact, 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 and I explain it with examples. But there are sometimes I go astray a little bit. And to battle that, I will prepare like a learning cheat sheet for you. I'm in preparation of this. Maybe I will show this after the lecture, and it will be ready in like the next or the next lecture. I mean, you need it for the exam, but I want you to have it ready for like you can look at this and say, okay, this is the factual knowledge I need. These are the explanations that he did in the video, and these are things that generally will help me, but might not be that important for the exam. However, I encourage you at least to understand everything apart from the that is marked very optional, right? So there's an optional thing that is purely optional, and I usually express that. Like the thing I just said, the Python example, this is purely optional. I encourage you to notice these things, but they are not required for the exam. However, general knowledge, like general factual knowledge, is usually good to have because it will help you understand the factual knowledge that you will need for the exam. So it's better to think like in these dimensions and to learn some analytical skills. However, they might not be required in the exam. So some analytical skills will of course be required, but not, I cannot like test every piece of it, obviously. So just so you know, I will prepare a cheat sheet that gives you even more structure than we have with this structure here. And speaking of structure, what's today's lecture agenda? Not only did we change colors here from red to blue, today we have the topic of data preparation, so data cleaning and data construction. So we basically, these two things, we look at data that we have, that we collected in data understanding, that we have looked at in data understanding. And as I said, data understanding and data preparation, they are very intertwined, right? So we look at data, we detect problems, and then we fix them in data preparation. So however, I showed you some problems in data understanding. At the end of data understanding, we looked at the problematic of outliers, and we also looked at the things of which is kind of connected. So outliers, anomalies, which can lead to, if it concerns our actual target variable, so our y variable that we want to predict. For example, we want to see if people commit credit card fraud. So we want to look at one transaction. So one transaction is one row, and want to predict for this transaction because we've never seen this transaction before. So we train a machine learning model at once that predicts for a transaction, is this a fraudulent transaction or not? So easy binary classification, right? We put it into one or other basket. Problem is obviously that in our data situation is a little bit skewed here. So we can detect this with data understanding, but now how do we fix it? And this will be the focus of today, but obviously we will need to look back a little bit on data understanding so that I can show you how we detect the actual problem. So just saying it's not always black and white. Like you can do these steps after each other, but this is usually kind of an iteration. So as we said, we iterate from here, we iterate here, we can iterate here, right? So we have multiple iterations in this process. This is not like we understand it, we do data understanding, data preparation, modeling, evaluation, then we're done. This is not how it works in practice. It's a lot of trial and error. And this is like the only advice I can give you is to really structure it that way, right? And see, kind of document what you did to the data, when it got worse, when it got better, like specifically evaluating these models, because in practice, it's not like you click and then it's there. Like this is a process, but as always, this is like an iterative process, right? So we have iterations here that are constructed that way. We have iterations. We have iterations here that go from here, or we go even there, right? Sometimes it should not happen, basically. So the business understanding is the only thing that should be fixed. So we should fix the problem at first. So rarely do we iterate iterate back to change the business understanding. It could be, right? So I say rarely because this is the thing we could manage. So this is a purely economical thing. But sometimes it's as simple as you meet like two people here that tell you everything about it, like what kind of databases you have, what kind of Excel sheets you have. Then you have a second person that says, oh, we also have the machine data, right? We also have the machine data here somewhere. Well, we have the robot data with the robot arm data. And we have another database here in the production, like this is a conveyor belt. We have data here. So we have all your, so they tell you about data sources, and then you put it all into your data, into one database. So let's call this the analytical database, ADB. That's not an official abbreviation. I just say this is an analytical database. So I'm just too lazy to write here. So if you watch this in DoD, this is not an official abbreviation. I just used it to make it simpler. Okay, so we put it everything in here, and then we start with data understanding. Based on this, we start with data understanding, we go to data preparation, then we have all these iterations, and suddenly we notice hopefully data understanding that or probably in the evaluation that the model is not good enough. So we are missing a lot of data, maybe a lot of variables that can help us. And then suddenly we ask back if there is anything else, and maybe some people say, okay, there are two other persons that can give you some ideas, or maybe you have to phone into another company. So if you have, for example, not another company, but another subsidiary, like, or another manufacturing plant, like BMW has, if we take BMW as an example, they have a lot of manufacturing plants all over the world. So maybe you ask other people, they say, hey, we have this and we have that. And then you get others. But usually it shouldn't be the case, because in business understanding is a fundamental thing. Like the constraints you have, the data that you have available, like it determines everything. Like it would be a drastic change, and you would have to calibrate a lot in data understanding, data preparation, modeling, and evaluation. Like these are not incremental changes. This is a fundamental change. For example, if something you have a good model, but then they say, oh no, we need a better model, or we need a model that is more stable, and then you need to retrain everything, and you need to make sure that you get a model that satisfies the new constraint that suddenly come up. So you really have to make sure that that you don't iterate too much to change the business understanding, because these iteration arrows mean you change something in data understanding. This means you change something in data preparation. This means you change something in modeling. And also the evaluation will usually show you like this is the quality thing, like how many stars do you have? Like this is the quality thing. And you will see this, how many stars you have. So this will be the step where you most often iterate back to other steps, right? So this iteration from evaluation to anything but maybe business understanding, these are the most common ones, obviously. Like these are the most common ones, like go to here, go to here. This is why I'm go to here. These are the most common ones, right? Okay, before we continue, to wake you up a little bit, besides coffee, mm, since we discussed this and I want to like stimulate your neurons a little bit, um, maybe you can name one or two cases where it might be appropriate to go back to business. I named one of them. You encounter new information, but what would be other cases where we have to where we have to go back to business understanding, although we might not want to. So this is not, I'm not talking about a voluntary thing where you are happy about. Every iteration will hurt you, obviously, but it will bring you the results, right? So um, maybe you can discuss this. So when might we want to go back to business understanding? So what are situations? You can also describe a general situation like that you have encountered maybe yourself or where you think, um, oh, in other words, why is business understanding, what is the role of business understanding? Why is it so important? And what are situations where we might have to go back? This is not an easy question, but I think I'll give you some minutes to think about because we always want to discuss this, right? So we know that it's hard to change anything here. So we don't want to go back. So this is like there's a magical barrier we don't want to overstep, but sometimes we have to. Um, and when would be a good idea? Yeah. Customer requests something in addition to the model. Yeah, this is a good one. So sometimes, and this is often, so the customer, they say, because usually what you do is you do this for a customer. So this is a very good point. And you meet with them and they say, hey, this is, give you a description of a problem. And then you usually show them something and they say, oh, but wouldn't it be good if, and this is the sentence that brings horror into your brain and eyes in practice, because this means you might need to go back to business understanding. I mean, it can have various degrees. It could change sometimes the fundamental problem. So, for example, if they say, "Oh, wouldn't it be good if we have a numeric estimator instead of a classification?" Like we just say, "Okay, credit card score, like we want a credit card score, or we want to have a fraud score. Like instead of having just like these fraudulent yes, no, we want in addition, we want to have a fraudulent score, right? Or we want to have like an anomaly detection and look at these things again. We want to have like explanations. Okay, so this is a very good point, actually. This is a very good point. So if customers are addition to the model, yeah. And also additionally, sometimes in deploy we don't have a deployment here, but it could be just as simple as changing something in the information systems, because we know this all the things we do here in the end is we basically deploy an information system, right? We deploy an information system into the company where people can inform themselves or that people work with that system. So for example, as we said, the example, the bank teller works with the system and the system gives advice and say, oh, this customer is not credit card worthy, or someone in the anti-fraud division works with the system and asks, okay, what transactions are actually marked as fraudulent by the system? And so it could be that the IS simply the surface or the user interface, all these things that they might not like it or they might want to have more information. And then because this is what they see, right? They see this thing. They don't see all these things. They don't see the model. They don't care about the evaluation, the data preparation, data understanding. They don't care about. So what? Because they speak another language. So basically you have business understanding This is what they understand. So this is customer. The customer sees business understanding and product. This is what they care about. And the end product, the product, which is the information system. So this is the product, right? So they see this. They don't see any step between. So what you have to do as the developer, right? What you have to do generally, and this is like basically your job, and this is very cruel for you. What you have to do as the developer. No, not green. Didn't I just? Sorry. As the developer, the dev, you have to care about. You have to translate this. You have to translate the comments of the customer, right? You have to translate this, right? Translate. You have to translate this into your language back again. So basically, what your job is to translate from the customer space that is a domain expert that knows about the business understanding, which you might not know much about, and translate it back to your steps, which are data understanding, data preparation, modeling, and your evaluation. So you have to translate it back to this realm. From BU to product, you have to translate this back. So if they say, oh, we would like to see some numbers that indicate something in the upper right corner of the user interface, you have to see, okay, how do we get these numbers? So you have to go back to business understanding, and you have to see, okay, what is the data mining problem, or what is the data science problem that we have? So this is also part your problem. So what's the new problem? And then you put this whole process in again, so you can deliver this part, right? Okay, when a circumstance for a task change due to some outside influence that forces that, yeah, very cool. So, for example, what about the concept drift? So the firm underwent a concept drift, the data. So this doesn't have to be from outside; it could also be from inside. So some processes within the company change, right? People get exchanged. There are new people. You get new data sources. Old data sources get like canceled. Small systems change. So everything these people tell you basically, right? So everything these people tell you are not correct anymore or need to be changed. Very good, right? So not only new from, it could also be new from outside. So it could be an outside person, but could also be that these informations are not like up to date anymore. After looking at the data, we realized that the problem was actually different than we would have thought before. Okay, so this is a tricky one. So we look at it. So the problem is always the problem. Now, what could happen? So Umar, I'm gonna translate it a little bit and say, what could happen is that we look at the data and we see that the data does not fit the problem that we have. So the data doesn't support a solution for the problem. So we need to go back and we need to tell them, hey, your data, we cannot use it. We cannot do anything. So yeah. So if we look at it like that way, it's a little difficult to say, okay, the data, we realize the problem, that the problem is different from the data. This is not the case, because the problem is the problem always. And this is maybe an important lecture here. Because the thinking that we look at the data and then change the problem is not what we should ever do. Like, we have a problem, we have a decision problem, we have a business problem, and we want to solve it. So what people have done in the past a lot when AI came up, before AI, it was big data. You probably have heard of big data. And so in big data, they had all these things, like they had all these databases, these NoSQL databases, the data lake architecture. So it was all big data. So it was all about storing all the data that we have. But what didn't they actually have? They had no problems for that. They just did it because everybody was doing it, right? So they cared more about the architecture. So they didn't actually know what to model or what to evaluate. So they just saved data. They just bought databases for high prices. They just saved, but they didn't have a problem. So it was not targeted at any problem. What to save, what to gather, right? So it was not bound to any problem, which means that later it was like, okay, we collect the data and we maybe see what we can do with it later. The problem is, usually you should have a goal, and then you collect the data that you want for this goal, or you look what you can, like you inventorize and say, okay, we need to collect this data, because chances are you save the data, you will never have all the data available because you don't really know what kind of prediction you want to do, what kind of problems, not doesn't have to be one problem. We learned that, like we could have an additional problem. So usually going from data to problem, so could also ask yourself, what kind of problem could I solve with this data? But this is correct. So we can, but usually the customer or you will set a problem, a goal, and then we will see if the data supports it. And if the data does not support it, we might have to go back here and say, hey, the data does not support it. So either we get more data somehow, that either we have to care about. So we need to look through all these databases here and have a question mark and look if they can, or we have to look for unknown databases, or we have to look for external data that is like external data that is not like Twitter, or it's X now, sorry, X, or social media data. Why do you think people care so much about the whole social media shebang? It gives a shitload of data to everybody, right? So data is, there was this saying like 10 years ago, data is the new gold, is the new resource, and it's not wrong, right? So why do people like give you something for your data? Like if you're willing to give them data, they usually give you something for free. You get maybe 10% off your next order or whatever. All these things, they are there to get your data, partially to get your data. Sometimes they want to retain you as a customer. However, they usually combine these things. So they get these external data because it helps them predict. It helps them predict, and prediction helps them to make more money, where we are back at our business understanding goal. So never ever forget business understanding. I will never, I don't want you ever to like just say, okay, we're going to build a linear regression. I mean, we need to learn how to do these things. And there will be a focus on this in the lecture series, since this is AI-based decision support 1. So there will be a focus here, because we are these people, the developers or the data analysts, right? This is what our role is. But if you don't understand the customer, if you don't understand this, you are isolated. Your job is no good, right? Because if you don't understand what the problem is, it doesn't matter how good you can build a decision tree on ANN or on SVM, which, by the way, we are not doing this semester. We're doing this next semester. So very important, okay? I heard the other day that we are running out of new data for AI-related training. Is that true? Okay, this is a good thing. So I want to briefly address this comment. Now, what we'll talk about here is like small data, like company data. What you are talking about is you're talking about training generative AI, like ChatGPT, right? So ChatGPT uses text data from the internet, right? So so this is optional, disclaimer optional, but since you ask, it's a very cool thing. So I want to distinguish something. So the problems we are talking about here means we have company data such as this, and we do a prediction, right? We predict the variable. For example, fraudulent transaction, yes, no. So when we have a set of possible solutions where we pick. So in this case, we have fraudulent, yes or no. So we have 2 options. So our model only needs to take care of 2 options. In generative AI, right? Generative AI, I will explain it very easily. So this is not true, or this does not resemble the complex. In generative AI, we basically do the same, but our options to predict are, let's say, there are very many options. Like it could be, it depends on what your tokens are. So for the sake, we could say, okay, we predict the next word. Okay, I'm gonna do it easy. We predict next word. Usually we know that it's not the next word, but part of words. This is why ChatGPT can create new words, because it's not on a word level. But for now, let's say predict next word. Okay. So, and then what it does is it creates a sentence by predicting the next word. And this is why they call generative AI, because they generate a sentence, and the sentence actually in itself is new, but the parts of the sentence are predictions like fraudulent, yes, no. It's nothing else, okay? In its core, it's the same. It needs way more power. So it cannot be done with a linear regression. So it needs way more complicated models that are called transformer models to predict the next word, to well predict the next word. Okay, but let's say we predict the next word. So why are we running out of data? Because so GenAI is usually trained in several steps. That the first step is the most important, or it's not really the most, but let's say every step is important, but the first step is the step you're talking about, Johannes. Okay, so what happens is for GenAI, we don't need to label the data. Now for this here, we need to label the data. We need to look at all transactions and we need to see, okay, this was fraudulent. So someone needs to come up and say, hey, this was fraudulent. It could be that it was automatically in the system, or if people haven't paid back their credit, we will know this and it will get a flag, haven't paid back, or fraudulent, yes, no, right? So we will have an easy data table. So here we predict the next word. And now I want you to think, why do we have for the next word of a sentence? Because GenAI generally only needs a general understanding of language. Now, let's say we have the internet at our disposal. Why do we have so much data? Why do we have so much data here? Because what's the goal is to predict the next word. What does our training data look like? Like, just think about it. Don't have to know anything about the models. Why do we have so much data out there? Right? Just think about it. The goal is to predict the next word based on the context we have so far in a sentence. So basically, she walks her. We want to predict the next word. Okay, she walks her. Okay, want to predict this one. Okay, and we have this as input. These are our features, basically. And this is our y variable that we want to predict, right? The true word y is, if we know the true word, if this is training, but we want to predict this one. This is what we want to predict, right? This is our y. So why do we have so much training data for this? It's obvious. Give me another example. She walks. Want to predict that one. So give you another example. She. Want to predict that one. Why do we have so much training data in the internet? Look at this. What do we need? What do we just need? What do we just need? Look at this. It's in your face. Look at this. This is text. This is a small piece of text. I want you to think about it. Because when we use it, we create more data every time. This is another problem. This is what we call self-sustaining AI, and it's a bad thing. But I'm just talking about, let's assume that we don't put the AI generated content back in the pool. But Gina, this is another very important point we can talk about in a few seconds. It's very simpler than that. What do you read on the internet? What do you read on the internet? Generally, the most general level, what do you read on the internet? You're all thinking way too complicated. Social media posts. You're reading social media posts. Okay, and what do they say? What do they? Yeah, we consume text. Yeah, text information. Yeah, text. And text is what we're looking for. Look at this. You have billions, more text. You just have text. When we search on Google source, yeah, everything is data. Everything is text. Like every website has text. Every text is everywhere. And all we're looking for is to generate an understanding on how we build a sentence, how we predict the next word. So our training data consists of examples like she walks her, like we have input variable. I'm gonna make it really simple for you. It's not that simple, but input variable is she walks her, and output variable is dog. Here input is she and output is walks. Here input is she walks and then output is her. So with this one sentence from the internet, we already generated 1, 2, 3 training examples with one simple sentence. And now you can imagine how text data, because all we need is texting. We don't need to label it because it's already labeled. The data preparation phase covers. This is my X, this is my Y. So I can also use this as X now. I can use this as Y. So I just predict the next word. So I have a lot of pairs where we have X next word, X next word. I have it all in. I just need the text and I don't have to label it, right? So text, information, whatever you want to call it. Like I would say text, and the text consists of information. And so basically these models, they are really good at finding what you want, like the context. So context, so it obviously learns what this word is based on the context given. Like what is the context of your prompt, and what is the most likely answer. So it's not a retrieval. It's really important to understand that we don't retrieve. So if you ask the AI to say, hey, can you explain to me what data preparation in the context of the CRISP-DM is? They have CRISP-DM, data preparation, right? And they just know the words because they have analyzed thousands and millions of posts where data preparation and CRISP-DM occur, right? And then they generate the words and the sentences. So what they do not do is they do not do a Google search basically and retrieve information. Now we know that GenAI has been augmented with RAG, which is retrieval augmentation. So it actually can search the internet, but it still generates text. So RAG, what they do is you have a query, like this is the user query, right? This is what you type into ChatGPT. Then ChatGPT says, okay, cool. I look at this. I do all my calculations, right? I do all my calculations. And what I do is I can augment this. So but I'm not like augmenting my output, but I'm augmenting the input with RAG. So I'm basically looking what is actually going on when I look at this. So I augment it with RAG to maybe find other words, find better synonyms. So I actually augment the input. So then I have a larger input, a better input, and then I only have one arrow because I augment the input, and then I get my output, right? She walks her dog. Okay. And to go back to the initial question of Johannes, running out of new data for AI-related training, we're not running out of data, but the important thing that you said here, what's the important word in Johannes's question? Or the statement that he put out? Are we really running out of data? Are we really running out of data? I would say no, we're not running out of data. But what are we running out of? There is a key word in the statement made by Johannes, or it was what he heard. Yeah, new. The word is new data. Very critical, new data, because we want generative AI to reason like humans, right? And for that, text data is at its end. Like we can do so many things. Like we can always improve the training of GPT. We can improve it with RAG. We can improve it with like nowadays we can have the chain of thought. Have you seen this? Like you can look at, okay, how did you get to this conclusion? But usually what we have is the chain of thought is correct, but the answer is still wrong. This is because these models still, they don't really think. They just generate text based on she walks her dog. This is still the central thing that they do. They predict the next word. They do it very, very well, and it seems like they can actually think and reason, but they cannot, right? So they have a chain of thought, right? And it's implemented, but they don't use this chain of thought because the chain of thought is also just predicting the next word. So the chain of thought is what makes sense, and it has some cool features, and this makes it's very good. Don't get me wrong, and it's not only prediction. Like this is not only trained like this. There are many more techniques that make it way better. Okay, I have to say that. So this is an extreme oversimplification that I do now. But the question is new. So what we need to do if we have new data, we need to like look at video of humans doing stuff, right? And this will get us the real new data. So having another sentence where they says, oh, she walks her dog, or another sentence about data preparation, it won't add too much new information. It won't make the GPT better because GPT already knows that, right? They already can predict very well around these common facts, right? So the question is, how can we get new data into this? And I think this is what's referring to. So we are running out of new data. We're not running out of data to strengthen what has already been there, but it's kind of pointless. So if you know about data preparation and you know about all the steps, you've worked there 20 years, me telling you about it, it's pointless. So I'm giving you the same information you already know, right? But if I teach you something that you don't know, right? For example, how RAG works and you don't know it, this will open your perspective for you. Now you can use the knowledge of RAG in the exam you write, in discussions, in papers that you write, in things that you do yourself. So, and it's about the new data. All right. So, and we want to go back to to go back to Gina, because when we use it, we create more data every time. So this is a dangerous thing. So what Gina said is that when we use this, we generate more data because it's a generative AI, right? So what we do is we generate new sentence like she walks her dog, right? So puts out she walks her dog, and if this AI generated content, which it does, goes back, for example, in social media. So a lot of social media content is obviously AI generated, like the text. We talk about text content, obviously also images and videos, and it finds the way back. Then what happens is we get this AI generated content, and AI generated text. It's something that has no extremes basically, because we're looking at the most probable word. So we're kind of going into more into the middle, where the extremes are less and less represented. But these are the things where we can learn from. These are the different things, but they are weighted very low, right? So if we have AI will predict the most probable word. The text goes back. That means that this context, the most probable context, gets strengthened if the AI is trained on that, because the AI looks at the most probable thing, and the most probable thing is the thing that occurs most often in this kind of context. Basically, there are some exceptions, so this is why ChatGPT is so good, or other LLMs are also good, because it's not that simple. But using my simplification, it's the way it will eventually become. So this is why it's dangerous, so that we create more AI data. We will live in a basically, not to doom it, I not want to doom it, but basically we're living in an average. Everything will go towards an average, right? So there's some creativity in the prompts. However, also the prompts for images, they work the same way. So if we use this data, we will only strengthen what is already there. It will not generate real new data, right? So this, I hope this helps, and we go back full circle there. So this is why it's a little bit complicated. And this is why it's dangerous. If you have time on another session, can you discuss about AI generated homogeneity people? Yeah, we can discuss it. We can also discuss it in after the lecture. But now I want to continue with data preparation. But I feel like these discussions are very important because they help us to understand also the difference that AI has taken. And this is, by the way, also a problem that we encounter in simple learning, like in shallow machine learning that you just said. So like if we don't have new data, everything we talked about in the last lecture is the same thing. this new data thing, it's about the parking lot, right? These are all problems we can go. The analogy, small child learns, we need to train a model in the end. And if the parking lot has only the same cars, right? The child will learn no variation of sports cars, and it will have a hard time detecting sports cars out in the world if the parking lot that the child learned from is not very good orchestrated, right? And this is what we learned in data understanding, where we said, okay, there is no variation in a variable. We can look at this with histograms, with variance, with standard deviation, with mean. We can see all these things. This is why we do the data understanding, to inspect the parking lot. How does the parking lot look and how can we fix it? And this is what we're here to learn about today. So let's have a look. Oh my God, we've just wasted a lot of time. It's not wasted time, it's good time, because discussing these things are very important. But again, for the people watching, this was an optional discussion based on a question, right? But I felt it was a good place to discuss it, right? Because as I said, it also relates to other problems. Now, if we all have the same text, if we don't have variation of the texts, right? If we don't have the Gen AI will not evolve. And the same is with our model. If our model can just detect a certain thing of fraudulent transaction, a certain thing of credit card fraud, or in using my analogy, just the child can only detect certain situation of sports cars and not all kinds of sports cars, it will not perform well in the application area that we put it in, right? So we want a model that can generalize well. And this is also a thing in evaluation where we will need a model that can generalize well. That means, okay, it's okay with the training data, but the training data will never occur again. It's the past. So we don't care about the quality of the training data. We care about the quality of data it has not seen before. And this is this is also true for the generative AI, right? So we don't care if the prompts that we already gave the generative AI are answered very well, because that it's trained on these prompts, right? This is, by the way, the second step. It is trained on prompts, and the third step is reinforcement learning through human feedback, optional. Okay, so finally we can learn how can we deal with the problem, with this parking lot problem, with some of the parking lot problems that we face, like with the training data problem. When I talk about parking lot, I always talk about training data, right? Problems with the training data. That the parking lot is the training data. This is my analogy with the small child. This is analogy world, and this is a machine learning world. Okay, so okay, let's see what are data preparations. So what I'm gonna do is I'm gonna skip these things here, and I'm gonna just use. We're just gonna say, why do we prepare data? Because it contains a lot of these things. Like you can read through it, but we lost some time, so I will skip it. It's just a formal definition, and it's all right if you like doing a project. But I feel like, why do we need to prepare data? The why is always important, and it's always a little shortcoming of some lectures. So some data preparation need for all data science applications. So usually that means that we have the data, and we have some kind of data, and we need to prepare it now. Okay, there are several steps in doing that. So our goal, our ultimate goal, is to produce a data set that helps us to make a good prediction. Okay, so this is our goal, right? So that the error prediction should be lower. So we want actually the classification error, or the error that indicates how bad our model is or how good our model is, if it in the evaluation step, to go down. So the error should go down, the prediction error should go down, or in other words, the prediction quality should go up. So, okay. So important lesson, garbage in, garbage out. Now, if we put really bad data in, we cannot say that our modeling step cannot magically pull one out of its head. It's not possible. So this is why data preparation is very, very important. So why prepare data? So usually there are kind of two roads that we can go here. The first road is more like a formal one. So sometimes the data just needs to be in a certain format. So the data can be good, right? Quality-wise. So data quality-wise, it can be good, but it's not in the right format. So this is just a technicality. We just have to format it. Like in Python, for example, LSTMs, that this is a deep learning model, need a certain vector form. So we need to just reformat our data table. Like we need to show them where's the timestamp, we need to transform it and so on. Or sometimes, and this is, I think I showed you last time in RapidMiner, that sometimes there's an error when I have, for example, a polynomial, so that means a nominal variable, target variable with multiple possible things. So it's not binary like yes, no, or fraudulent like yes, no, but it can have more than two outcomes. So for example, we want to classify a flower. There's this really cool ICES data set where we can like look at flowers based on their iris, not ice, sorry, ice. The iris data set. I'm sorry, the iris data set. And so for example, in the iris data set, iris has three classes. And some classifiers cannot handle this. So for example, if you look at RapidMiner, you will get an error. So we just have to like deal with it somehow, and we will do this in data preparation. Yeah. So then data is dirty. So it means that we have problems. So that means that the data itself would technically work, right? So this is like technical. This is like a technicality. So technical. So technical means if we don't do it, it doesn't work at all. We cannot click the button to train the model, right? So, and the other thing is like, this is like data quality, like DQ data quality. So that means if we click the button, it works, but it will be bad. So, or maybe it won't be bad, but usually this means that there are some data problems. And we will focus on these because this is really dependent on the situation. So this is something you will encounter when programming, right? So we will more focus on the data quality thing because this is universal and we need to fix this. And so we have like incomplete data, like lacking attribute values, lacking certain attributes of interest, or containing only aggregate data, like occupation equals, but we don't have the data, like missing values is a large one. It can be noisy, so we have like things that we don't want in there, like there could be variables that we don't want in there or contain errors or outliers, like we have a salary of -10 or someone has age 22 and obviously type the 2 one more time. Inconsistent discrepancies in codes or names, like age is 42, we have birthday, right? So it doesn't really work. So person couldn't be 42 that was born on that day. So there's a discrepancy. In the one table, it's rating 1, 2, 3, and now it's ABC. Discrepancy between duplicate records. So this is really a thing that happens a lot when you remember, I want to let's go back. You remember this where every person said, hey, look, I have data here, I have data here, and we integrate this. So this step right here, this happens a lot in that step, right? So when you remember this, in this step, like if we have multiple data sources, right? And we want to integrate them, right? So this is maybe an ERP system. So maybe SAP, this could be your SAP system. Then we have like a manufacturing system, production planning, for example, production planning system. And then we have like maybe some wild Excel files from some people that just have Excel files lying around. Okay, so some Excel files here. Okay, tables. And then we need to integrate them all into one large data table. And So we need to fix a lot of these things like inconsistencies we need to fix here. And this process, by the way, to like harmonizing this, you might have heard this. This is a little bit information systems now, but this is called ETL: extraction, transformation, and load. Okay, this is optional. You don't need to. This is part of business intelligence, BI, BI knowledge or information systems knowledge. But I feel like you will hear this a lot. So extraction, transformation, and load. Okay, so this means that we get this thing, and then once we have it all in one source, we can like look at incomplete, noisy, and so on. So this is more about dealing with inconsistencies and having all in one table. That doesn't mean to solve the ETL doesn't solve every data problem. Okay, we can basically deal with it in the ETL process if we like to. But this is just an automation. Like we load this data into our database, like for example, every Sunday. We say, okay, we automate an ETL process. Okay. All right. Now, these are some things that can happen, and we will talk about them one by one. Now, the question is why we do that, right? So this is still why. And I promised you I will tell you, okay, what's the deal with what does it have an effect on modeling, right? So, and to show you this, what I have here is I have an easy modeling example. So we have a regression. If you do not know what a regression is, this is a really easy regression where we have one variable. So we have one feature. We have one feature and one target variable. So this is the easiest it gets. We want to predict the target variable, which is y. So target variable is yi. So we have four target variables here, and the feature is xi. Okay, so we want to use xi to predict yi. Okay, so this is the most easiest thing we could do. And here I give you the model. It's a regression. So regression means it's an easy model that says, hey, look at this. We model this value, whatever it is. In dependency, we have a constant, right? It's actually, you can see the constant right here. I think it's not exactly 4, but so we have a constant. We have a constant, theta 0 plus theta 1, theta I times xi. So this is the model. It's nothing. It's really easy model, right? And so I think the constant is around 4. You can see that theta 0 is around 4. But it doesn't really matter. And we use this to predict. So whenever we predict it, what do I mean by prediction is, okay, we train the model on the orange bubbles here, and then we get this line. So we get this line. And what do I mean by training? So the orange bubbles here, this is training data. Training data. So we train the line on the orange bubble. So in this here, the line is our trained model. It's really easy. Trained model. And by trained, I mean these variables become actual numbers, right? So actually it's something like 4 plus, what is it? 6, maybe something like 1.25 times xi. So, okay, so these become values. So this is the trained model, right? This is the trained model. So we train this using we get the parameter values here. These are called parameters by just training the model. We don't discuss how the training works. This will come later. We somehow use the orange bubbles to train the blue line. Okay, that's all you need to know right now. Okay. All right. And so we get this as a result, we get the blue line, and now we can predict. And by prediction means we get now we put this model into action. So we implement it into an information system. Someone comes in and says, okay, what's your X value, right? Now let's say we want to predict, someone says, hey, my X value, whatever it is 16. Then we put it into the model and we get back our Y. And this is our prediction. So it's maybe 10.5. So we predict 10.5 for an X of 16 using our model. This is what the prediction looks like. And we want this model to predict new values as good as it can, because this is where we will use it, right? We will not use it to be good on the training data. However, in this case, I want to show you what training data, so the parking lot, how the parking lot can mess with modeling, because this is the connection we need to make, right? You remember that we have to go back and iterate, and I want to show you. So by the way, if you want to Google this is called the Anscombe quartet or the Anscombe data. This data is generated totally artificial, and it has one purpose, to show you what we can fuck up. Okay, so let's look at the upper left corner. The upper left corner, we have the training data. So as you can see, the only thing that changes from the pictures is the training data, the orange bubbles. This is the only thing that changes. The model is always the same. And it's not the same because we said it the same, but it's the same because it gets trained the same. So it's an artificial data that always gets, so that we always get the same linear regression model. Now, we have one assumption, that is we use a linear regression model that looks like this. We use this model always, and we train it based on the orange bubbles. And the surprise here is, it's not really a surprise because it's synthetically, synthetically forced that way, that we always get the same linear model, although the training data is completely different. And we will see how this plays out and why it's important to look at data and why it's even more important to deal with the data preparation step. Okay, so now, as I said, the upper left is the good one. So this is basically where this will work, right? So this is good. So we can pick why, because we can see the orange bubbles, they are here and they look okay, and we just built a regression model here, right? And so regression model here. Now, what I also might need to add that all the models have the same, if we evaluate them in the last step, they have the same prediction quality. They all have the same value that they return, right? Same prediction quality. This is very important. It's the same model and it has the same prediction quality, right? Okay. All right. However, this is not tested on test data, right? This is just tested on the training data, right? So this is very important. It has the same quality on the training data, right? And we will discuss two things. First, why it is bad to just use the training data as evaluation. We will come back to this in the evaluation. And why we need to deal with some data problems. Okay. Next one. Top right corner. This one right here. Okay, this one. So we look at this, and now as I said, the only thing changed are the orange bubbles. Now we look at this, and what do you see? Now what I want from you is analytical thinking. You don't need to know anything about regression. So don't come and say something like, oh, it's overfitting or all this bullshit. I just want to know what you see. So this is like, I want you to be a 5-year-old child now and tell me what you see and tell me, does it fit? Yes, no, what could be a problem, right? With this one right here, when you look at it. Because this is the first step in analytical thinking, looking at it and then thinking of a solution and maybe also thinking of what's wrong with it, right? So, as I said, if we just look at the evaluation numbers, they are all the same for all the fours. So we cannot rely on that. Now, what's the problem here? What would be a problem here? And we will discuss many things here. But this is a core thing where you need to think. And I don't want you to overcomplicate it, like telling me something to impress or something. Just look at it like a 5-year-old. Like the question is the model good? Right? And by good, we mean, does the model fit the data, right? So this is like our inspection. And now if you were a 5-year-old child and I would ask you, does the line fit the yellow bubbles? What would you say to me? Let's have a look. Why data creates specific shapes? Why data creates specific shapes? You mean, what do you mean by shape? You mean this shape? Yeah, that's the point, but why data creates specific shape? Oh, you would ask me why the bubbles are that way? Oh yeah. Yeah, so something like that. But it could be even more easier, right? So um Kami, what does it mean? Like we're comparing the blue line to the orange bubbles, right? Why data creates specific shapes like line curves. Yeah, so it goes into the right direction, right? But let's wait for some other answers. I won't let you go off that easy. You need to analyze this. You need to know what's wrong here. Don't try to overthink it. Like Kami is right on the money here, actually. Different geometrical forms. Yeah. So this is what a child would say. It would say, okay, hey, what a child doesn't see like the points, right? The child, what does the child see? The child sees this, right? XY doesn't fit. It looks more like a quadratic regression. The model is too simple. Yeah, this is what a 5-year-old would say, Tristan. They would say, X2 doesn't fit. The model is too simple. It looks like a quadratic regression. I know though, what kind of children do you have? Okay, send them to me. Okay, we will make like, we'll win a Nobel Prize in no time. Yeah, but you're correct, of course. Tristan is correct with the professional analysis of this, right? But I hope that, as I said, if you have a child that says what Tristan says, please like take good care of it. It will go far. No, yeah, that's correct. So we have the shapes are different, right? So um, actually the line doesn't fit a linear model doesn't fit a quadratic. This is like somewhat a quadratic um, shape or the opposite. Like it would probably be more something like this. But you see, it's a quadratic shape. That means no, it's actually a minus square. So if we go like this, it would go like this. So it's minus x square shape. So, and what kind of problems, if we now talk about the prediction model, does it bring with it? Now, as I said, the quality is still okay. So the quality is the same as this one, right, from the data. However, now what happens if we use this model to predict a new data point, right? So this is what I always want you to imagine. Now, if we have a new data point here that lies within that follows the same, and now we come to the core of it that follows the same data generating process. This is what I talked about last time. Data generating process. Everything is a process. Everything you observe is the result of a process, right? So if we observe a temperature reading, this is the result of the machine working, right? If we look at the product, like if I look at this mug and I have like some quality issues with it, it's because in the production, somehow in the production, something went wrong. Okay. Or maybe a painter didn't paint it if it was hand painted, maybe, or even I broke it a little bit or whatever. Right. Everything we observe is part of a process. So the data generating process of this observation, by observation, I mean the orange bubbles, right? So we need to act that these orange bubbles, they are part of a data generating process. And our model needs, in essence, to capture this process, need, in essence, to reflect on this process. Now, let me ask you, the true process is given by the orange bubbles. And as Tristan said, this looks more like a quadratic. This looks more like a quadratic data. Like this looks more like data from a quadratic function somehow. So let's say we have a new data point. Now the new data point would not be here. obviously, because it doesn't fit the data generating process. But the new data point would rather be here, right? So the new data point would rather be here. Get rid of this one. Would rather be here, which means that the prediction of this one, right, of this data point would be like, data point would be here. So the truth, this would be the truth, right, would be around 4. And what the actual model does, the model would predict like 10 point something, as you can see here, right? So it would be very, very bad. Actually, the model would not serve its predictive purpose. It would have very bad prediction quality, right? Because because it doesn't fit the data generating process. Okay. So this is like doesn't fit DGP, right? So this is important, right? So, okay. So let me just see. Data generating process. So next one, bottom left corner, right? So again, 5-year-old, not Tristan's 5-year-old, but really 5-year-old. Look at this, right? By the way, just to go back to Tristan's answer, that Tristan is correct. We would here fit a quadratic regression. Like obviously we would not fit a line, but we would fit something like a model that is more like, here would fit a model that is more like yi equals maybe some things, and then we would have here times x I squared, and probably this coefficient here will be negative. So this will be a negative coefficient because the form is like this, right? So this will probably be negative. All right, now we look at this bottom left corner. Look at the orange bubbles. So these two are kind of similar, address kind of a similar problem, to be honest. But they both show different types. So the right type usually doesn't occur in that way, but it's both are addressing a phenomenon that you love, and you love to write it in the exam, because I've never written the word more often in an exam than this one, probably, except for is or have or so students love to, this is like the favorite topic of students. So if you look at the orange bubbles, and if you're like 5 years old, you can speak, what would you say? Like, first of all, just look at or isolate the orange, forget about the line, and just look at the orange bubbles. What would you say? I know you might think I'm just kidding you or teasing you. I really want you to look at things and first of all, have an easy to understand sentence, and then ask yourself, why is this the case and how can we deal with it? But if you fail to analyze it on a general level, and you just think, okay, what is this? Is this an ANN? What kind of data preparation is this? What kind of, I need to know, I need to write down for the exam. No. You need to identify it first. And just relax and describe it. You can describe this without knowing anything about data preparation or data mining or data science or machine learning at all. You can be 5 years old and you can completely describe the phenomenon. Okay, the one data point is much higher than the others, not following the pattern. Yeah, okay. So yeah, this is what you see. Okay, you will say, okay, this is a line, and we have one data point that is kind of that deviates. So we have this data point. Okay, looks like it. So if we would use like professional wording, what would be maybe a more professional non-5-year-old term for this? This is the term you all love. What would you consider this to be? There is an outlier, I knew it. You love everybody. Yes, it's correct. First of all, it's correct. But why I'm saying this is because every time I have a data preparation task in the exam, immediately, even if it's not correct, people write outlier. This is like the thing you always, like they automatically write outlier. Even sometimes I think they don't even read the question. They just write outlier on that page. So in an exam situation, there might be an outlier situation, but not always. Okay, so be a little bit careful. But yeah, this could be an outlier situation. Now we need to discuss this again because we already discussed outliers and anomalies, and like I say outlier. Usually, I personally use outlier when it's more of a general thing, so we don't know if if the outlier is due to a mistake, right? So it's just wrong data, or it's just data that shouldn't be there, or is it because it's an anomaly? So something that really can happen in that is part of the data generating process. So the difference between an outlier that is not part of the data generating process is that it really comes from a mistake. Something happened and somebody fucked up or the system fucks up, but it's not within the data generating an anomaly can actually happen. So this data point can actually be generated from the process. And it's very hard to distinguish the two sometimes if we go into deep discussion. Now, what does this point do here? Now, it's very easy to see that this point in the training data affects the line. And now I want you to, now you can take the line into account, right? So what does the point do with the line? How does the point affect the model? How does the outlier affect the model? This is the next step. Step by step, easy, and then you get it together. It's more complex, but what does the point do with the model here, with our trained model? Or you can ask yourself, what would happen if the point wasn't there? Same, by the way, for this one. So what does this point do with the model? The points shift the model upward. Now it does not fit the rest of the data anymore. Yeah. So to be honest, it still fits a lot of the data, right? But as I said, so this has, you have to imagine that all of these have the same prediction quality now, right? So in terms of the training data, that means that this model has the same quality as this model, where the data situation doesn't look that good. It may mislead us. Oh yeah, it definitely will mislead us. So yeah, perfect. So thanks for the nice answers. They are all correct. So we see that this one shifts the line upwards, because if this was not there, right, it would be a perfect line with 100% prediction quality, right? So what happens now basically is if I add another point. So we know that we have two options here. As I said, we have to discuss if this is part of the DGP, then we have to make a decision. We have to make, oh yeah, the outlier increases deviation, definitely. So this is why we look at the deviation, by the way, right? Also, so but we also need to look at the data and max and min and stuff like this to actually see if it's fault of an outlier. So now we have the discussion is, by the way, the same for this one here. So this is basically, we can discuss them. We will look at this separately, but this is basically the same idea. So we need to discuss if this point is part of the data generating process. and it can happen, then we really need to discuss, do we want a model that somehow accounts for this? Because, or do we just say, okay, we are fine with covering most of the cases, and we are fine with an anomaly occurring, if this is part of the DGP, an anomaly occurring from time to time. This is the discussion we need to do. This is the discussion you have. And where does this come from? Where do we get the solution? We get it from business understanding. What are the constraints in our process? What are the constraints regarding our prediction quality? Can we let one go from time to time where we know we will be way off, right, with our prediction? Because what happens is, so the question is, do we want an almost perfect prediction almost all the time? Or do we want like a mixed prediction, but we can maybe predict this more closely? However, as you can see, so this is somewhat a lackluster solution. We do not perfectly cover either of the case now, but the prediction of the outlier is not that bad. However, it's not that good either. So what would you do? Let's say this is an anomaly. Let's say this is an anomaly. So it is part of it is part of data generating process. So it is, we cannot confirm that this was somehow an error that almost never occurs. Like it could occur in the future, okay? So let's say we have, what would you do? So what would you do? The question is, do you remove this from the training data? Or do you keep it in the training data? So basically, do you want the blue line or do you want the red line? This is the question. Blue pill or red pill? What's it gonna be? May want to discuss this in the chat. This is the last thing we're gonna do today, but this is very important. We need to, I need to show why we need to do data preparation. Why we also, it's not always black and white, right? So what do you do here? What would you do? There's obviously not a correct, and I would remove it. Okay, you would remove it. Okay. So, I could tell you I would remove it too, but it depends on the business understanding. Like, what is the goal? Like, it could also be that the goal is to actually identify things like that, right? It's somewhat, but apart from that, if we say I'm all right with having a model that predicts most of the cases very well, and somehow there would be a case that it does not predict very well, because let's look what would happen. Now we know that this is the training data. So usually our new data points would be here and here. So this could be data points with of course, the data points could be here and here. So let's say these are our new data points, right? These are data points we've never seen before. Now we know that here the prediction is not gets worse, right? So it could be that this is outside of the scope, so that the usual points are just within that range. So this would be okay-ish, because here we only have like this. But it could be that the prediction here gets worse. Okay. But also the prediction of this one is not very good. So if we have a new point, a new anomaly that is up here, let's assume anomalies are always here in that cluster. We have a second anomaly here, right? The prediction would also be not good, but only slightly better, because you have to see that anomalies, they only slightly put it to the top. They don't extremely divert it, because it depends on how far they are away. And it depends on how strong they are compared to the other numbers of points. Okay, so and get more. I would remove and get more data instead of. Oh, but this is kind of controversial. So if you would remove it and get more data. So you remove this and get more data, but if in getting more data you will get more anomalies, because if it's part of the data generating process, you will encounter this also. So what you ultimately do is you will get the same situation all over again. So getting more data, first of all, if you write in the exam, just get more data, it's not really a good answer because usually we can't. Usually you can, as either I give you a hint that you really need to get more data, or usually it's not like, oh, we forgot to mention we can get more data. So usually we assume in this that when we are on data preparation that we already got most of the data, right? So you have to see. This is why we use a process. You cannot just say at the end, oh, we need to get more data. I mean, it's possible since it's iterative. So we can like just say, okay, at the evaluation, when we see the model doesn't work, and also when you say get more data, specify it. Do we need to get more variables or do we just need to get more rows of data? Get more data is a very lackluster answer, and it's usually not rewarded. Like you can say, hey, we need more variables. That means, okay, we need more variables means that our model is bullshit at the end, and we need more variables, or we need more rows of data, like we need the same variables, but more cases, right? So I don't know what you mean here, right? So you really have to distinguish variables. I mean, oh, you need to get more variables. Oh yeah, in this example, we only have one variable. So yeah, okay. Okay, do you mean that sometimes we have to accept anomalies, outliers based on the business context? Oh yeah, absolutely. I mean, the question is you have to decide this and you have to talk with them. Now, what happens here is if they are part of the data generating process and not an error, you will discuss it. You need to make sure, okay, these anomalies, right? How well do you want to predict them? How well do you want to predict them? Are they going to be part of your prediction, or are you okay with just predicting the normal? Because anomalies are not the normal; they occur very rarely, and you have to decide: does your model take them into account at all, or you just remove them to train the models? They will appear anyway. You cannot do anything about this. You remove them from the training data. You do not remove them from the real world. So you have this red line here. This is your model after you remove the whole thing, right? This is your red line model. However, the anomaly will still occur, and you will still use this model to predict it, right? So this is maybe something you. Oh my god. So you have to use it, right? So let's say here this is another anomaly point. So it will happen. The anomaly points will happen either way. There is no way around them. You don't know when they will occur. Maybe they are even an error and they will never. You don't know. But usually you can be maybe a bit sure that they will occur, but they are very rarely occur. And then you make the decision that you will from time to time have these blue lines here with bad predictions that can cause you some trouble economically because you need to see what decision is based on these predictions, right? And then you have to look at it. And if you say, okay, I can accept to lose some money once in a while when my other predictions are pretty fine. It's a business understanding thing. This is what I'm saying. Is this to show that if we don't properly, maybe don't test regression sums, we could end up with a result that looks right, but is actually wrong? Oh yeah, this is what I mean. Like technically it all works. Technically you can press the button. There is nothing, when we look at this, like technically this all works. However, these anomalies can influence your model. And this is just one case. We will learn other cases next week, okay? So for now, since we're done with the lecture today, I want to thank you all for your attention and joining. Next week, we will continue with data preparation. I hope you got an idea on why is it important to do that. And as always, if you have questions, feel free to ask right now. Thank you so much.